everyone see my screen now? Yes? Good? Awesome. Great. Oh, sorry. Can I just plug in my computer really quick? It's running low on battery. Okay, cool. So yeah, so today we're talking about higher order functions, right? And higher order functions is going to be the first day of a 2-day session on functions. And basically the big surprise, if I was kind of play spoiler a little bit here, it's just that, well, functions are pretty much just like objects in a lot of ways too. And so we're going to see how we're going to be able to use that going forward in our daily coding practices as well. So to start off, right, why are functions so special in JavaScript? And the answer is they're actually not, right? They may seem that way when we first start off, but really when we think about functions at the end of the day is they're also just like any other data type in the sense that they're like strings, they're like arrays, they're like objects, and therefore we're actually able to use them in the same way as well. So what do I mean? What I mean when I say we're able to use functions like we do the other data types? Well, with other data types, we're able to pass them into functions, right? If I want to, pass in a string or pass in a number, and I'm also able to return them from functions, right? So if I say, if I give you two numbers, can you return their sum to me? Well, I can return that number in a function, right? And so if I can return a number, then that means I can also return another function as well. So let's take a look at kind of see cases in which that's actually kind of in practice. So here, if I have an array, and hopefully this is now second nature to us, right? If I push in, if I have an empty array and I push in a string 3 times, well, by the end of it, my array is going to have three strings in it, right? However, if I have an empty array and afterwards I write a function on line 5, just so we're clear, right now at the end of line 7 here, we've created this function called happy function, but we have not, and I repeat, we have not actually run the function yet, right? We have not invoked the function because the only way to invoke a function is to say the name of the function followed by an open and close parentheses. Here we have that, but that's only as part of the function definition, right? So once again, and I cannot emphasize this enough, at this point in the code, when we hit line 7, we've only created a function. We have not run the function, or we have not invoked the function yet. Okay, so if I take that function and I do amazing array.push happy function, happy function, happy function three times, well, in the previous array, when I pushed in a string 3 times, I got an array of 3 strings. Here, when I push in a function into an array 3 times, I get back an array of 3 functions. Don't worry too much about the way it printed out and the inner brackets. That doesn't mean that those are nested arrays. It's just the way functions print out in JavaScript. The takeaway here for us should just be that in the same way that I was able to add a string into an array, I am also able to add a function into an array. And this is building up to this bigger idea that that we can actually treat functions in most cases like we treat any other data type. So here, if for example, if I go back to the previous example where I have my happy function, and here I've just created an array with that function 3 times. Once again, right, on lines 4 through 6, I've created a function. On line 8, I've created an array with that function in there 3 times. But at the end of line 8, up to now, I have not run happy function a single time yet, right? I've created it, I've put it in a place, but I have not used it yet. I have not invoked the function yet. If I did want to invoke the function, for example, if I want to invoke the first instance of happy function in amazing array, well, here's where we kind of need to once again be very comfortable and fall back to our idea of how do I invoke a function. Well, the only way to invoke a function is to say the name of that function followed by an open and close parentheses. And so if I walk through this for loop here that I've written on lines 10 through 13, right? On line 10, I've created a for loop in which I start I at 0. I iterate, I go from I is less than the array.length, I++. So I'm just going through every single element in the array effectively. On line 11, I created this variable called element, and I say let element equal the element at that index, right? Let element equal amazing array index of I. And then on line 12, I do element open and close parentheses. So I'm actually invoking element here. And so now when I do this, as my for loop runs, the for loop is going to run 3 times, and each time I'm going to invoke the element at that index. And so effectively, I'm invoking the happy function at index 0 once, I'm invoking the happy function at index 1 once, and then I'm also invoking the happy function at index 2 once, right? I'm basically going through every single element in the array, which we've already seen plenty of, and now all I'm saying is, well, because I know it's a function, let me invoke it, right? So on line 12 there, the element invoked is the same thing as invoking each element inside the amazing array, which happens to be a function. Does this make sense to folks so far? Right, I'm not done anything crazy, right? All I've done is put functions in an array, and then I've invoked it. So far, those two things are both things we've definitely seen in other contexts, but maybe not just linked together yet. So, is there any questions on this before I move on to the next session, the next section?
How come the functions don't have parentheses after them within the array?
Because what does putting a parenthesis after a function mean?
It's running it?
Yeah, and so on line 8, am I trying to run the functions?
No, you're just storing them.
Exactly, and so that's why the open and close parentheses aren't there, right? Because if I on line 8, all I'm doing is putting the function in the array. I'm not running the functions yet.
So you're not actually running it until line 12, right?
Exactly.
Okay, thanks.
Cool. So let's move on to the next line here. Passing values into functions, right? So here I have a function called logs a type that takes in a specific value, and all it does console log out the type of that value. So on line 7, when I input a string, I get back string, right? So once again, a very traditional function, nothing fancy here just yet. But as you can probably kind of start guessing, right? Here I was able to pass a string into a logs type function. Well, what's to stop me from passing functions into other functions? And the answer is no. It is nothing, right? Nothing stopping me from doing it. So on line 6, I still have my logs type function, but now on line 10, I create a function called happy function, right? We go back to our old happy function, and on line 14, we invoke logs type, and we pass happy function into the logs type function. Right? Once again, here, notice how we are invoking logs a type. We are not invoking happy function. And once again, this is the biggest mistake that I see folks make here, right? Is that they see happy function and they think everywhere that they see the words happy functions, it means we're running the function. And that's not true. We only invoke the function when we have an open and close parentheses after it, right? If I'm trying to pass a value back and forth, I'm not trying to invoke it. I'm just trying to pass it back and forth. And so therefore, I don't need the open and close parentheses after it. So here, when I look at line 14, right, logs a type, and I pass in happy function, that takes me back to line 6, where the parameter value is equal to the happy function. On line 7, all I do is console log out type of happy function, which is going to give me back the word function, because a type of function is a function. Right? And so here we're starting to see this pattern where we have a function that is able to take or return another function. And so we call these functions higher order functions. The terminology isn't particularly important, and call it whatever you want. But just know that when we talk about higher order functions, all we mean is this is a function that is designed to handle or do something with another function. And so if we go back once again to the previous example, right? If we actually want to invoke, a function that is being passed in, well, the only way to run a function in JavaScript, once again, to hopefully really drive this point home, is to invoke or run that function. And so on line 3, we have this function called calls a function that takes in something called another function. And on line 4, we invoke another function because we see the open and close parentheses after function. And let me just delete this really quickly. This is something that that's something that I'll cover in a little bit. Okay, so here on line 7, I create my happy function, and then on line 12, what I do is I actually invoke calls a function, and I pass in happy function, right? And so when I do that, what actually happens is on line 12 is I invoke calls a function, and I pass in happy function. Once again, on line 12, notice how happy function is not invoked, right? Where I'm just passing it in as a variable. Another function that takes me to line 3, where the variable another function becomes happy function. And when I invoke another function, that's the same as me actually invoking happy function. And therefore, I get a console log out of I am happy. On line 9, the return that's commented out, that's just to show that, remember how in JavaScript, every single function returns something, and if you don't tell it what to return, then you're implicitly returning undefined. Everyone still with me so far?
Hey, I have a quick question.
Go ahead.
So on the slide before, you said
Yep.
log a type, and then happy when we invoke happy function there. I thought I just want to make sure I didn't misunderstand you that we are evoking logs a type, but not evoking happy function, which is why there aren't parentheses after happy function in there.
Yep.
But then on this next slide, you were just mentioning that we are indeed evoking happy function when we put it in calls a function. I'm a little confused now.
Yep.
on that.
Because so if I go back to this logs type example, right? If I look at line 6, whatever function I pass in is stored under this parameter called value, right? And on line 7, all I do is console log out type of value. And so all I'm doing with value is I'm effectively assessing what type value is and printing it out. If I look at this function here, then on calls a function, on line 12, when I pass in happy function into calls a function, happy function is stored under the parameter on another function. But the important part is on line 4 there, what am I doing with another function? I'm invoking it, right? Because on line 4, I have another function with an open and closed parentheses after it, which means I'm invoking another function, and therefore I am invoking happy function. And so,
Okay.
and so that was what was missing in the previous example, was that we never invoked the parameter that was being passed in. Here we actually are on line 4.
Okay, cool. Thanks.
Yep. Any other questions? All right, sounds good. Okay, cool. I mean, this is pretty much the crux of today's lesson. So if this makes sense to you, then we are in very great shape. So now we're just gonna kind of, not tediously, but we are gonna go through just a few more examples of the same ideas. Except now what we're gonna do is we're actually gonna start thinking about this idea of return as well, right? So let's take a look. Here on lines 1 through 3, I have this function called says hi that takes in a name and console logs out hi name. On lines 5 through 7, I have a function called says by that takes in a name and just says and just console logs out by name, right? On line 9, I have this function called calls with name that takes in two parameters. One is called name and one is called callback. And look what we're doing on line 10 there. We are invoking the callback parameter or the callback variable with the variable name. Okay. And so what does that mean in real life when I actually invoke it? Well, so on line 13, when I actually invoke calls with name, I pass in Sadie as my first parameter, so that becomes name on line 9. And then on line 13, I invoke the says hi, or I pass in the says hi function, which is being stored as the callback parameter. And so on line 13, when I actually invoke that function, what happens is I invoke callback, which effectively in this case is says hi. So I'm invoking says hi, and I'm passing in name, which is Sadie. And then on line 14, I'm doing the same exact thing, except now rather than having callback be says hi, it's now says bye. And so after when I invoke line 14, I am invoking the callback, which is says bye. So I am invoking says bye, and I'm passing in the name, which is Sadie. And so when I look at my printouts, I get hi Sadie followed by bye Sadie.
Hey, David.
Yes.
So in line 9, function calls with name.
Yep.
Name, if you just saw that line number 9,
Mm-hmm.
you assume that name is a string and callback is a function, or that line doesn't really necessarily mean that name is a string and callback is a function.
Yeah, good question. So generally speaking, if you're looking at kind of good code, variables should be descriptive in representing what they are, but they don't have to be, right? And so if I saw that line of code, I could assume that name is a string and callback is a function, but if I run the code and it doesn't work, then I will definitely go back and re-examine to see if that's the case or not. I guess to answer your question more directly is there's nothing that explicitly says name has to be a string and callback has to be a function, and so therefore, so therefore we can kind of we should be more careful, especially if that's not the case, right? And so if that's not the case, then usually it probably reflects poorly on the code writer, and that they weren't detailed enough in how they named their variables.
Right. Corollary to that question, so if what you said is true, on line 10, you could completely have a different function there. I don't know, say goodbye, parent's name.
Yeah. So if I rename my callback parameter to be says goodbye, then on line 10 I would just call it says goodbye, right? Like line 9, the name and callback are just variable names. They could be anything.
Yeah.
Yeah, no problem. Cool. So yep, so this is just an example of us invoking callback functions. And so now we're going to start moving into the world of returns just slightly here. And this is where I think maybe things get a little bit more confusing. Hopefully not too much. But let me just walk through this item item. Here on lines 1 through 3, I have this function called add world that takes in a string, and now it returns, right? The return is very important here. It returns string plus the string world. On line 5, I have a function called calls with hello that takes in a parameter called func. And what it does is it invokes func, it passes in the string hello, and it returns whatever that function returns. Okay, so this is a case in which we need to be very, very, very careful that at all points we know exactly what function is being invoked and what's being returned. And then lastly, on line 9, we actually invoke calls with hello and we with the add world function, and we store the outcome or the return value in this variable called result on line 9. Okay, so let's walk through this step by step. What's actually happening? Well, on line 9, on the right hand side of the equal sign, we're invoking calls with hello, and we're passing in add world as the parameter. So that just means on line 5 there, we will invoke the calls with hello function. We take in a parameter called func, which is equal to the add world function, and then we go to line 6, right? Func is the add world function, and so on line 6, when we invoke func, that's the same as us invoking add world and passing in hello as the first argument. So what happens when we invoke add world? Well, let's us now go back to line 1, right? Because that's where the add world function is. When I invoke add world function, I take in the string as the parameter, and so therefore, in our case, because on line 6 we invoked add world with the string hello, that means the variable string equals hello on line 1, and on line 2 we return the string hello plus the string world, which basically becomes returning the string hello world. So that gets returned to line 6, right? And so line 6 becomes return the string hello world, and so that gets returned now back to line 9, and so then we get let result equal hello world, and when I console log out result, I get hello world. Okay, so it's a little bit of a more involved process, but realize that fundamentally all we're doing is and this is actually a really big part of programming, is can you just logically follow us as we get from step 1 to step 2 to 3, etc., right? Does this logical string make sense? And so once again, hopefully this, what I verbally walked through made a bit of sense. But all we're really doing is we're just calling functions, returning the values, and then calling functions and returning the values. So everyone good up to here? Okay, let me rephrase that. Is anyone not good with here?
David,
Yes.
apologize. It was way too fast for me. Can you kindly
Sure.
The logic again, which came first? Because I mean, if lines 1 to 3 came after lines 5 to 7, would what you said have made a difference?
No, it wouldn't have, right? Because lines 1 through 3 is creating a function, we're not using it. Lines 5 through 7 is creating a function, we're not using it. So it doesn't actually matter the order in which we create these functions. What matters a lot more is the order in which we call them, right? So how about this? Why don't you walk us through line 9 then?
Wait, can I ask another question first
Go
before I
ahead.
do? So when you return the function, yeah, no, okay, I understand. So that wasn't even a question. Okay, so
Cool.
result equals calls with hello add world. So calls with hello is a function
Mm-hmm.
which you defined in 5 to 7,
Yep.
and so you need to pass add world into that function. Says this is where I got confused. So 5 to 7 says return function, but only as it passes a string into that function world, right? So you need to pass add world into the calls with hello function, which is on 5 to 7.
Mm-hmm.
But then you need to pass hello into the add world function, which is in 1 to 3.
Mm-hmm.
Did I say that right?
Yeah, I mean, I think it might make more sense if you, so rather than trying to evaluate the code as a whole, like walk through it the way a computer would, which is very sequentially line by line.
Mm-hmm.
Okay, so I execute line 9, right? And it says I need to execute calls with hello and pass in at world, right? So that takes me to line 5. What happens next?
You invoke the function func.
Okay, and so what did that? And okay, so then what happens next after that?
So that's where I get that. So func, the what you pass into func is hello in a string hello, but func is now add world.
Mm-hmm. So what line comes next?
So so then the because it's add, so then you need to go to line 2,
Mm-hmm.
and because the string was hello, you need to replace this so on line 2 it says you need to return string plus the string world.
Mm-hmm.
Hello, the string now on line 2 is now hello from line 6. Is
Mm-hmm.
that correct?
Yep.
Okay.
So finish the function.
Oh, and then okay, so then the result will be really at the end of the day
No,
line.
no, no. Stop. Line by line. Don't
Okay.
try to jump too far ahead. Just line by line.
Oh, okay. So I got to line 2 now, right?
Yep.
I got to line 2. So string now becomes hello plus world.
Mm-hmm.
But then you need to go back to line 9, don't you?
So what do I do? So let's finish line 2 first.
Okay. Line 2 returns the string hello, uh, the string hello, and the string world.
Is it returning two things?
Um, it's concatenated, right, with the plus sign. Um, I don't know actually. Returning two things, two strings. That's your question, right? Is it returning two strings or one string?
Yep.
Um, I think two strings.
Does Have we ever seen a function that's returned more than one thing?
Oh no, just one. We always return just one thing.
Okay. So what does it mean here then?
So 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 hello in the string hello gets combined with the string world into just one thing.
Okay, and what's that one thing?
Hello world.
Okay, and then what do we do with it?
Um, you need to go to console log.
What do we do with the string hello world?
Oh,
We're on line 2 still.
the string hello world. You that then becomes shit. I don't know. Hello world then becomes the result.
Okay, I mean, I guess what I was looking for is we return it, right?
Okay, yes.
Right? So here's what I mean when I say like when you read the code, like it's really helpful to just read it step by step, right? The way a computer would. So if the variable string is equal to the string hello, then in the order of operations, the first thing we would do is string plus the string world. So that gives us one string, hello world. And then line 2 says, great, now return the string hello world. So we return that string. Right? So that's like sequentially what the computer will be doing if we were to run this block of code.
Okay, but that's not the end of it, right?
No, it's not. So what comes next?
Um, console log
Where?
on line 10.
So we go from line 2 straight to line 10.
Oh, do you have to go back to 9?
Well, it's an order, right? It's an order in which we do things. And so the question is, after we do line 2, where do we leave off last?
Line 9.
Not quite.
No?
Nope.
Line 2.
Does anyone want to help her? Where do we leave off?
I was gonna say that we had left off on. I mean, we started the whole thing because we declared a variable on 9. But result.
So we did not leave off
that
on.
we set equal to all that stuff that you guys just
And
described.
then 6 returns the function, which goes straight into the result, and then the result prints.
Okay, sorry. I think people overlapped there a little bit, so I couldn't quite hear. So after line 2, where do we go back to?
From line 2, it goes to line 6. It's returning the string hello world.
Mm-hmm.
It's returning that string to calls with. It returns that string to where you called it, which was at calls with hello add world. Then it sets result equal to the return, which is hello world, and then it prints the result.
Yep. So yeah. So remember, the way that computer works is like, and it's kind of makes sense, right? If you think about the way kind of humans do things too, like if I was assembling like a toy, right, and I had to assemble, let's say I had a doll, I had to put on the arms, the legs, and the head. Well, I wouldn't just I wouldn't assemble the arms first, and after I do that, I just move on to another doll entirely, right? I would then assemble the legs and the head. So it matters where you left off. And so once again, if I was to kind of walk this code back in sequence, right? The very first step I did was on line 9 is I invoked calls with hello and I passed in the function add world. That took me to line 6, and line 6 says, great, now invoke add world and pass in hello. So that takes me to line 2, right? Once I finish line 2, I then go back to where I left off, and where I left off was line 6. So then that requires me to finish line 6, right? And so what does func, or in this case add world, invoke with hello equals to? Well, on line 2 it says return the string hello world, so line 6 becomes return hello world. And so then where do I go after line 6? Well, where was line 6 invoked? Line 6 was invoked on the right hand side of line 9. And so the right-hand side of line 9 becomes the string hello world. And on line 9, I'm just saying let result equal hello world. And only then am I done with line 9, so I can move on to line 10. Does that make sense, everyone?
Yep.
Charmaine, does that make sense?
Hello, David, can you hear me?
Yep.
Yeah, sorry, I was on mute. So yeah, it makes sense. I think what was throwing me off was that func had a parameter just is a string called hello. So from line 2, which is already hello world, I'm going back to a function that's a string called hello. It threw me off.
Sure. So
You see what I'm asking, right? I was already at hello world on line 2. If I went back to 6, I'd be back to just hello.
that's not true. Yeah, that's not or at least that's not what the variables are equal to at that point in time, right? So actually, so everyone can see my screen, right? I'm just gonna type over. Actually, no, I'm gonna make a copy of this. I'm gonna make a copy of this, and then I'm gonna run it again down here. But now I'm gonna actually write over it. Okay. So first things first. Let result equal calls with hello, right? And I pass in add world. So what does this mean? This means now func becomes what?
Func becomes add world.
Yep. Funcs becomes add world. And I'll make this a comment just so we know that. So then this becomes what?
Oh, that becomes add world where the string is hello.
Yep.
Oh,
Great.
okay.
Great. So now we're here, right? Now add world. So what is string equal to?
Hello.
Yep. String is equal to hello. And so here, what does this string become?
Hello as well.
Yep. Okay. And so now let's take a look at this. So now I have to do this order of operations first, right? So what does this become?
Hello world one string.
Great. And so now this returns hello world, right? And so now I'm done with this row, right? Because I'm going to return hello world. The question now is where do I return to? Well, I remember to wherever it was being called, right? And now this is where I was being called, right? So now I replace this with hello world. And now the question becomes, where do I return this hello world to on line 19? Well, I return this hello world to wherever it was being called, and it was being called here, right? So now I boil it down to this, and that's why when I console log out result, I get back the string hello world.
Brilliant. Okay, I finally understand. Thank you.
No problem.
Oh. Okay.
Yeah. Does anyone else have any questions?
That was really helpful. Thank you so much.
Yeah, no problem. And I'll share this on the Slack channel in a little bit too. I guess you guys have had the video, but yeah. Cool.
You're recording this? That's cool.
Yeah, I've been recording every lecture I've ever done.
Yeah. For some reason, usually there's a little thing that says that. Anyway, yay, that's great. That was really helpful.
At least I hope I'm recording it. I think I am. Let me check.
Sorry, I didn't mean to make you panic.
No, it's recording, so we're good.
Oh yeah.
Okay, good. Let me just.
Thank you, David. That was really helpful. Thank you.
Great, awesome. Yeah. So that's this calls with hello example. And then, like I said, we're just gonna go through a few more examples of this as well, right? Here we have this function called say to all, and we take in once again two parameters. One is called names, and the second parameter is called say with name func. Okay, we named it whatever we wanted to. Usually the names should be descriptive, but once again, they aren't necessarily always correct. So just kind of keep that in the back of your mind. On line 2, all we're saying is great. Let's go through names, which I'm going to assume based on the fact I'm using it with a for loop, that it's an array. And then on line 3, all I'm doing is I am invoking the say with name func, and I'm passing in each element in names, right? I'm invoking say was name func, and I'm passing in names index I, right? The element at that index in the names array. And so essentially, if I just kind of describe this more in plain English, I give you a list of names, I give you a function, and all this is doing is calling that function with every single element in names, in the names array. And so here, if I have like my array as these group of 4 names, and my say hello with name just says hello, and then whatever name I pass in, and I call say to all, and I pass in group, which is the array of 4 names, and then my say with name func is the say hello with name function. Well, when I do that, all I'm gonna do is I'm gonna iterate through every single name in the names array, and I'm going to invoke the say hello with name for that name. Everyone so good so far?
Thank you.
Cool. So, and this is just a kind of a minor note. We talked a little bit, we kind of briefly looked at anonymous functions a while back. But this is just to say that we can also pass in anonymous functions in there as well, right? So this page of code is it is identical to the previous page. The only difference here is on line 10 there, right? I invoke say with all. I still pass in group as my first argument, but my second argument is I just pass in the function directly, right? I don't store the function in a variable and then pass in a variable. I just pass in the function directly. But other than that, everything else operates in the same exact way, right? When I get into line 3 there, the say with name func, the say with name func is still a function, right? It's the second argument that I've created between lines 11 through 13.
So when, just out of curiosity, when would you do this? Because I'm pretty sure that this is the only time it's referenced in the lecture.
Yep.
Like why you would have to essentially know what function say to all is doing before you wrote the function into as an argument.
Yeah, so I mean, anonymous functions are primarily used for functions that are only going to be used once, and so it's a little bit of a design decision in that, or rather, a design shortcut, if you will. The idea is if I'm going to create a function that I'm going to use once right away, like there's no point in storing it, right? I can just kind of use it right away. And so anonymous functions, generally speaking, are used when they are created for a single purpose and they're used right away. You don't have to do it that way. If you want to store every function you make into a variable and then call that variable, that's totally fine too.
The only reason that you wouldn't just write it directly into the say to all function is because eventually you would just want to possibly change it.
Oh, I see your question. Yeah. So you wouldn't. So the reason why you wouldn't do that is because you might want to call say to all with another function later on, right? Using an anonymous function doesn't. It gives you. It helps you save the trouble of storing it. But say to all is designed to take in any function, right? So if I create another function called says hi with name,
yeah,
I could pass that into say to all. So the fact that say to all has is taking in a function as a parameter makes the say to all function very, very flexible. It doesn't reflect upon the anonymous function.
But that means, but just to make sure, you can only really then use say to all if you know what the code in say to all is already, and then you can like type in a function as a parameter to like alter that. But you'd have to kind of know what say to all is.
I'm not following.
Never mind. I mean, it's a question. Don't worry about it.
Sure. So I mean, I guess I'll just do the kind of the follow up here, right? If I do this, okay. So there we go. So there's a say to all, right? So here, all I'm saying is we can make this an anonymous function here, right? If I also say, let David equal, and I'll just copy this function here, and it says, hi, right? I could also say to all, right, and pass in group, and then pass in David, right? And so now I can invoke this say to all function. I can pass in 2 different things. In this example, I pass in the anonymous function. Here I pass in another function, but I never need to redefine say with name. So by doing it this way, I've now made this say to all function very flexible because I can pass in any function I want as a second argument, and it will be able to execute it.
Hey, David. So
Yep.
then you're able to invoke David in the say to all function, how do you invoke the anonymous function?
Well, so here, I guess we can say that, you know, if I look at just this block of code here, right? I am basically saying let say with name func equal anonymous function, and I'm defining it this way, right? And then when I get down to line 42 there, I have been saying let say with name func equal David, right? Because say with name func ultimately just equals the second argument that's being passed into say to all, right? Here the second argument is this anonymous function, and then here the second argument is this variable which is tied to a function.
So it's just function. The anonymous function is just function.
Anonymous function is just a function. The idea is that we don't store it in a variable, right? And like I said, like the point of anonymous function is that I want to create it and then use it right away. And so, which means if I get to line 37 and I want to know, oh, hey, what was that function I passed into say to all? I wouldn't be able to access it.
But that function, but that
Hey,
anonymous function
Lauren,
is,
I think your mic's on. Sorry, go ahead, Charmaine.
but that anonymous function is always just function. So on line 33,
Yep,
the anonymous function is function, right?
yep. And there's no name, right? We're not storing any variable name.
Correct. And you can call it anything. It can be called anonymous parent's name.
Yeah, we can call this function anything we want, right? But the point of an anonymous function is that you don't give it a name.
You don't give it a name. Okay,
Because
got
by
it.
giving a name, what we were basically saying is you're storing it somewhere in your memory, for example.
Right.
And here our goal is say, hey, I just need to use it. I don't need to store it, right? It's the same reason why like we have something like this, and like the reason why this is so shorthanded, right? As just I is because we're saying we're only gonna use it in this for loop, and then afterwards we're gonna forget about it.
Got it. Okay. Thank you. That's clear. Thanks.
Yep. Cool. So that's the say to all function. And then so if I just do a few more examples here, function plus takes in num1 and num2, returns num1 and num2. Minus function takes in num1 and num2, subtracts the 2. And then on line 9 I have this function called calc. It takes in name1, takes in an operation func, and takes in a num2. And so here on line 10, if I just what do I want calc to do? I want calc to invoke the operation func and pass in num1 and num2. So if I look at what happens here, right, on line 13, I'm invoking calc and I'm passing in 10, the function plus, and the number 20. And then beneath it, I'm invoking calc, I'm passing the number 50, I'm passing the function minus, and then passing the function, the number 10, right? So on line 13 there, calc 10 plus 20, that if I go inside the calc function, that takes me to line 10, which boils down to return plus and passing in 10 comma 20 as my two arguments. And then if that takes me back to line 2 now, where it says just return num1, which is 10, plus num2, which is 20, so return 30. That takes me back to line 10, and then line 10 says return 30. And so line 13 becomes console.log out 30. And then I follow the same operation process. 50, the function minus, and then num2 as 10. I get back subtract 50 minus 10, which is 40. And so my console log is going to be 40. And then last but not least, we have something called a for each loop. So there's a few of these, and I wouldn't stress too much about this. But this is actually kind of like the we're going to talk more about this tomorrow, or I guess Monday. But this is kind of like actually a part reason why higher order functions exist is because what happens is you actually have a lot of functions in JavaScript that are designed to take in another function. Okay, and so for each is an example of this. So for each is a built-in JavaScript feature. Every array comes with a for each, much like how every array comes with a .indexOf function or a .slice function, right? Every array comes with a .for each function, and it's a callback. And so what that means is for each accepts a function as the argument, and only a function. And so here, if I take a look at what that looks like, right? On line 1, I have this function, I have this array called bridges. That's an array of 3 bridges. I have a function that just takes in log uppercase string, that takes in a string and just returns that string but capitalized. And now on line 7, all I do is this. all I do is I do bridges.forEach. I pass in the function log uppercase. And so that begs the question, what does for each do? Well, what for each does is for each is actually a shortcut that will invoke whatever function you give it, in this case log uppercase. It will invoke it for every single element in your array. And when it invokes that function, it will call it and will pass in a number of things. It will pass in a number of things as the arguments. And so what it will pass in essentially is it will pass in three things, always in that order. It will pass in the element, it will pass in the index of the element, and it will pass in the entire array itself. And so why is this, I mean, and I know this is going to be confusing right now, right? But if we just kind of walk through it step by step, for each is going to be a function, kind of like a for loop, right? It's going to go through every single element in the array. And for every single element in the array, it's going to invoke the function that you give it. In this example here, the function we give it is log with idx. Okay, so it's going to invoke log with idx for each element in the array. But the question becomes, what do we pass into log with idx when we invoke it? And what for each it says is, hey, I will always pass in three things to you in a very specific order for any function you give me that I invoke. And those three things are going to be the element, the index, and the array. Okay, so using for each requires you to know that order, and it requires you to understand the contract in which you're using it, right? Which means if I give for each a function, my function better be set up so that it is prepared to take in the element as the first argument, the index as the second argument, and the array as the third argument, assuming I want to actually use those values. If I need just the element, like in the previous example, then my function, I pass in, only needs to take in the first argument, right? But if I want to use, for example, the array, which is the third argument, well, then I need to set up my function that I pass into my for each loop with three arguments, because I know that if I need the third thing, for each will always pass in the array to me as the third element.
So just to confirm, there's no way, if we just wanted the array and not the index, there's no way to skip over that index to the array. You have to have all three?
Yep, because the contract with for each is it says I'm going to give you these three things in these three orders. You can accept them and not use them, but you have to, but I can only give them to you in this order.
Okay, got it. Thanks.
How come on the actual console log it doesn't print that and this is the array at the end?
I think I might have added that later. My bad. Let's actually run this.
In the pre-recorded lecture, it didn't have the array in there.
Yeah, I might have added that previously. Let me just run this really quick. So let me just comment out all of this here. And it should just work out of the box.
But you're just saying that the for each, if it asks for a third element, it'll just give it the whole array.
Yep.
Okay.
Yeah, that's what I thought I was going to. All right, thank you.
Yep. Yeah, I'll remove that. I definitely see how that can be confusing.
Would you mind if there's time stepping through these last two slides like you did that other one?
Sure. So.
Visual Studio.
Yep. So, yeah. So this is so if I had to recreate, for example, the for each function, right? Okay. So here we see this idea called bridges.forEach log with idx. So I'll say this is like the for each way, and then I'll say this is the for loop way, because and please keep this just in mind, right? For each is a shortcut. It's a way for us to do a bunch of things that we normally do. So that it saves us trouble having to manually write it out. The idea is that here is that like it's a shortcut, and so we're making trade-off for simplicity via customizability, right? So if I was to write whatever I want to do with a for each in a traditional for loop, what I would do is I would have something like this: let I equal 0, because I still want to iterate through every single element in my array. And then here, what I would do is I would invoke log with idx. I'm invoking it, and I'm invoking it with bridges index I, and then followed by I, followed by bridges. So these 3 lines are identical to this line.
Mm-hmm.
It's just, as you can tell, this is slightly less writing.
Would you mind doing like that calc example real quick that way?
I don't think we used for each for calc, did we?
No, I just didn't have a chance to ask you when you were on.
Here? Yep. Like this slide?
No, the calc one. Yeah, I'm sorry. Yes, that one. Yeah.
Okay, so did you just want to
I
like
mean, if you have time.
well, why don't you step us through this then? Let's do line 13 then.
Okay, well, this is probably more time consuming than you doing it, but I'll give it a go. All right, so we're saying let's put these arguments 10, plus, and 20 into calc. So then we go up to line 9, and we replace those with that. And then we're going to return I mean, this is kind of why, yeah, it's going to be painful. That's why I wanted you to do it. I don't really know where, I guess operation blank has become plus, so we're going to return whatever the result of plus on num1 and num2 is.
Well, I mean,
not totally clear. Oh, then that's defined in line 1.
okay, so let's try to be more specific with our words. Just because when we're doing this, right, like it.
No, I mean, I'm not. Yeah, that's why I was hoping you could maybe do it out, because I couldn't follow what you said quickly enough to really retain it.
Okay, but if you remember what I said yesterday, right, like me explaining it and having it make sense is very different than you being able to do it. So
Oh,
let's
I agree.
so
Yeah,
so let's do this.
but I'm not there yet.
Okay, so let's get rid of the console log too. Let's just make this super easy for ourselves. Okay,
Okay.
so on line 69, right? I'm invoking calc and I'm passing in these 3 things. So let's just I'm gonna make these comments, right? But let's just figure out what each of these variables are. Go ahead.
Mm-hmm. Okay, so num1 is 10.
Okay. Yep.
Operation func is plus.
Yep.
And num2 is 20.
Okay. Great. So great. So now that we
Num2
have
is 20? Oh.
yeah, so we have these. Great. So now what? So now let's start replacing the things on line 69, right?
Mm-hmm.
Okay. So where do you want to start?
So it's plus becomes plus with the arguments 10 and 20.
Great. Okay. Great. So 20. So where do we go now?
I'm not too sure. I guess we. So we've done that. So I guess we put that. We go back up to 57.
Okay. Why?
57.
Why?
It was a guess. I really don't know.
Okay.
You just have to follow the variables. So like whatever the variable is defined at, you just kind of like reverse engineer it.
Yeah, I mean that stayed in my head for the other one, but it's just not happening right now.
Okay, so basically, so we've replaced things, right? So we've replaced a bunch of variables, but we haven't actually run anything yet, right? So now
Sure.
our next run is we have to run this. So what does running this mean?
It will do whatever plus says with the arguments 10 and 20.
Yep.
So I guess it'll be okay. So it'll return 30.
Well, right. So but it's like so let's just step by step, even though your intuition is completely correct. So what does plus
Oh.
do?
Plus takes two arguments and adds them.
Okay, so which line of code does that take us to?
57.
Great. And so now we're on 57, right? And let's do what we did earlier here. Let's redefine some of the parameters that we've gotten right. So we have num1 and num2. And so what's num1?
10 and 20.
Great. So then let's replace, let's go to line 60 now and let's start replacing things. What should I replace?
Num1 with 10 and num2 with 20.
Yep. So then what's 10 plus 20?
30.
Great. And so now I'm returning 30, right?
Mm-hmm.
And where do I return 30 to?
To the middle argument on line 70.
Not
or maybe
quite.
you're just done.
Nope.
No?
Remember, like when I invoke a function, right? So, okay. So maybe I haven't kind of used it as an analogy with you guys yet. When I call a function, right? It's like saying like I'm asking, for example, I'm asking someone to do a report for me. Let's say I'm a manager, right? I'm asking someone to do a report for me. Once that person does a report, what do they usually have to do to kind of get it completed? The answer is they have to hand it to me, right? Like if I say, hey, can you get me a report or even get me, let's say, coffee, right? Like you getting coffee is great, but then if you don't give it to me, it's kind of like the transaction isn't complete, right? And so the reason why I use that analogy here is because here when I say let's try to figure out what this is, right? This is us asking for coffee, right? This is us asking, hey, plus function, can you do this thing for us, right? Can you get us coffee? And then we get to line 60 and the plus function is like, great, I have coffee. And so what's the final step? The final step is getting the coffee to whoever asked you for it, right? And so here the answer is, let's get our answer to whoever asked us for it. And so who was asking us for the answer? Well, it was line 67, right? This is where we initially called a plus. And so here's where we return the value to. Does that make sense?
So 30 gets returned to line 67 before it gets dealt with in the end.
Yep. So now that becomes 30. And then same exact idea again, right? So where do we return 30 to on line 67?
70.
Right.
Line 70. The calc.
Right,
Okay.
because this we
That's
called
right,
all of this
yeah.
to call calc, right? So now this becomes, let's do it here. So this becomes 30, right?
Yeah.
And if I go back to the slide, this is the 30 that we printed out for
Right.
line 13.
Yep. Okay. Thank you so much. I'm sure there's a range of us who were able to grasp that the first time around, but I was not one of them.
It's not a race. I know I missed the first lecture with you guys, unfortunately. But what I usually say is like we have 13 sections, and no matter how fast people go, we're only going to be able to cover those 13. So it really is not a race. Yeah, cool. And so that's pretty much, I think, for each, and then we go back to our recap. But yeah, that's pretty much it for today. Are there any questions about anything really that we've covered so far?
It's helpful. Thank you, David.
Yeah. Cool. Last call for questions before we break us up into the breakout rooms.